Hello everybody, in this section I will show you how to plot this two-dimensional heat map and also a side plot to help you give the summary of each row. Also, first of all, we clear the environment, clear the figure also, dock it in. And we need to talk about the data structure. We need to generate this kind of map. We loaded the previous saved data, which is a matrix C, and this C is a 68 by 68 matrix with double floats numbers in it. And I click it, I open it, and you can see this matrix is pretty much sparse. Most of the values are 0, and with some positive number scarcely distributed among it. And in this kind of data, we don't want to build a surface. We want to plot these points, these non-zero points, exactly as it is. And also we want to use color to indicate the values for each of the point. So we don't need to generate a mesh, which we used for plot a three-dimensional surface or contour. We only need the data stored in a matrix, and then apply image function. Here, image SC is a modified version of image function, which use full range of the color map, which don't give too much difference. I think you can play around with it. Then, so we generate the axis, and we receive the axis by axis handles. And now we focus on the mainDataAxes here, the bigger one, and then we plot the matrix. You can see it here. And also we receive the handle by H. And here the image function is similar like plots or bar, although it plots a surface, a two-dimensional surface instead of a line. But they don't have fundamental difference in terms of it returns a handle, which is also a random number. You can see here. And now we see that the blank zero zones on the matrix is colored by blue because the default color map is jet, and jet, the color method is nothing but a range of array of colors, which is encoded by RGB coding method. If I evaluate jet, you can see the feedback is a 3-column matrix, and each row represents the data. From here, RGB, so this is blue for 0, and then goes to the yellow and the red, and finally you have a red for the highest value. That's the reason you have all the zeros colors blue. So if you want to change this color method, we want to change the background, the zero data into white. What we do is we change the color method. We change jet. First of all, we assign jet to some other variable j, and then we modify j a little bit, and we only modify the first row of it. You see the first row of j is here, which is blue at present, and then we give it a new color, which is 111, gives you white. And let's check. Now the first row of j is 111, and now we use this j, which is a slightly modified matrix from jet, which represents the color coding method. We call this j with color map. You see, everything are the same except the 0 data points are white now. And we add a color bar. You see, 0 is white, and it has a discontinuous between 0 and 0.001. And now we can also change some detailed properties about this color map. First of all, I want to set up the range of the data which will be colored. Here you see the top of the color coding is close to 1, but it's not 1 yet. Sometimes when you make movies or import different data, you want to keep the same consistent coloring method for all the figures you generated. So here is a way to set up to fix the color range you are using. First of all, we get the parent of this current figure, which gives us the axis handle. So get h is the handle for the image function. So here give you the axis handle, and then we get the color limit of this axis handle, which is from 0 to 9.9997. And now I can set this range to 1, precisely 1. Not big deal for this one, as you see. And also you can set it to some special values, like here you only color the data from 0.3 to 0.7. And of course the best way to color the map for individual map is to use the full color range for the range of the data. So you use this chunk of code. Alright, next part I will show you how to change the ticks and the labels on the axis. First of all, let's add a line to this map. I will add a line here, and the line is the syntax for line function is here. This is x1, y1, which is this point, and then x2, y2, which is I think it's this point. And we have width and color. Color is in RGB, so this means gray color. And another line. You see, I intendedly gave a little bit shorter here to show you that you can stop the line any place you want. Also, you can add a line this direction, whatever you want. And also, next I will change the ticks here. Here you have numbers, but these numbers don't have too much sense for my purpose. So I will remove these numbers and instead replace it with some more meaningful labels. Here I get a current figure, which returns us a handle for this current axis. Then we set the property xtick as 17 and 53, which is about this location and this location. And then we use label as part of A and part B. And we want to remove the tick length. We don't need a tick here anymore. Let's see the result. Haha, yeah, what we want that. And also we can do the same thing for the y-axis. But the problem is that if you set a similar way, you get a tick label horizontally for the y-axis. A little bit ugly. You can give it a try. But what I do is I remove the tick. I simply remove the tick for y-axis. Then I use y label, a little bit trick to label this y-axis. And also you notice here the y label part, I use a lot of space here to make it look quite proper. And also here I use right arrow after a slash, which can be interpreted as a right arrow. It looks different from you directly typing by keyboard as a right arrow, left arrow. Actually, in this label part, the syntax from LaTeX can be interpreted within the label. So you can add some Greek letter like beta, alpha, sigma, or whatever. Like give you a case, show you that theta, and execute. Now you get theta here. Of course, you need to follow backslash here. And then I will summary. I will average all the data points on each of the row, and plot the average value on this set axis. First, I get average value. Then I focus on this axis zone, and then I use bar plot. It's a h. This h means horizontal bar, so you see the bar this way, not the vertical bar. And though I call it a HIS, histogram axis, basically it's not histogram. It's just a bar plot, similar to a line plot with which realized by a plot function. And here we want to reverse the direction of the axis. Get the current figure and set the x direction reverse, and adjust the limit of the y range. So this requires some detailed tuning. You want exactly one column corresponding to one row. You are clear enough to make it yourself. Label, and then save the figure. This concludes our tutorial. See you next time.